Here we're going to look at equivalent fractions, which is the same as reducing, except we work backwards when we reduce. So we first start with 1/3, and we're going to fill in 1/3. And now we want to make an equivalent fraction. So to make something that's worth the same amount, but looks differently. So we're never going to change our coloring. We're never going to change the outside shape. It's got to be the same size to be equivalent. And then we're going to change how many pieces are in it. So let's take now I can't stop here and say I have 4 pieces, so I have 2 out of 4. All the slices have to be equal, so I'm going to divide each of those thirds. And now I have 6 equal pieces, so I can write 6 as my denominator. And how many are shaded in red now? There's 2 shaded in red. If we don't want to do a visual every single time, because sometimes we're working with really large numbers and we don't want to divide a rectangle into pieces of 30 or 100, we have to think about how did this 1 become a 2? Well, we timesed 1 by 2, which equals 2. And 3 times 2 is 6. And that's where our rule of whatever you do to the top, you do to the bottom. Whatever you do to the bottom, you do to the top. This multiple here, we're using our multiples, never changes. So let's say I wanted to make another equivalent fraction, and I'm going to times 2/6 by 3. I'm going to have 6, and I'm going to times this one by 3. And this is me showing my work, just these quick little multiplication pieces. And 6 times 3 is 18. And now I have another equivalent fraction. And if I wanted to show that on my diagram, probably the easiest way is I'm going to divide my piece into 3 this way. So now all my little pieces are same sizes, and there's 6 colored in red and 18 overall. Now reducing fractions works the same way, we're just working backwards. So we're going from the larger number down to something smaller. So what's the opposite of multiplication? Right, division. So let's look at what we have down here. We know our denominator is going to be 8. And let's color in 4 of these pieces. So you've done some type of math operation, or you've solved a problem, and you get the answer 4/8. Well, you're never done. You always want your answers in reduced form, so we've got to make it smaller. Now we're not looking at multiples, we're looking at factors. What's a common factor between 4 and 8? Well, the factors of 4 are 1, 2, and 4. The factors of 8 are 1, 2, and 4, and 8. So 2 is a common factor, as well as 4. You always want to try and take the larger of the common factors. If you don't, that's okay, but you're just going to have to do your steps a couple times. So we're going to do the steps a couple times so you can see that it'll work if we started with 2 rather than starting with 4. So if we divide 4 by 2, because we know 4 and 8 are even numbers, so that's probably our first thought is, well, I can take half of 4 and half of 8. So let's see what we get. And now we have 2/4. And if I show that on my diagram, I can just get rid of, oh, that's not it. I'll just get rid of this middle line. And our diagram now has 4 slices. And there's still that 2 of them colored in. we can reduce it down even further. So let's take this one step further and reduce it again. And I'm going to have to divide by 2 this time because now I'm looking at these ones. Again, when I do the top, I'm going to do the bottom, and I have 1 over 2. And had I gotten rid of this line, there's 2 overall pieces. Oops. And one of them is colored in red. Okay, again, equal sizes. So like I said at the beginning, I could have gone from 4/8, which is 50% or 1/2, and I could have divided by 4 the first time, and 4 divided by 4 is 1, 4 divided by 8 is 2, and that got me the same answers. So it doesn't matter which process you take, they'll both get you the same way. It's just how well you recognize your multiples and your factors.